Okay, good morning, everybody, or wherever you are. Good morning to me. Well, thanks for joining this week's Tips and Tricks webinar. Today's topic is utilizing mutual TLS with Log Exporter. Please use the Q&A chat if you have any questions during this webinar, and we'll make sure we answer those. Our presenter today is a security engineer from Pennsylvania, Michael Ibarra. Michael, the floor is yours.
All right. Yes, thank you, Rob. And hello, everyone. It's great to be with you this morning, or as Rob said, maybe afternoon, evening. But I'm eager to share with you some things I've learned recently in my own research and testing as it relates to this topic. So I'm hoping you'll find it interesting and useful wherever your role and your work take you. So let's dive in. The map for our time together today, we're going to begin with a brief refresher on what Log Exporter is and what it does, and some detail around why mutual TLS authentication is important and what you'll need to get it working in your environment. Finally, we'll bring all these things together with a demo and a QA session. So, what is Log Exporter? Maybe you've heard of it, maybe it's a new topic, but it's essentially a process that forwards smart log entries from a management server or a logging server to an external third-party device. It can be a SIM, it can be a syslog server, it can be something like Splunk. And the idea is that we're forwarding those logs for visibility, compliance, and auditing, to name just a few things. Like I said, it can run on pretty much any Smart One appliance, physical, virtual, and even Smart One cloud. And it can run on either a management server or a dedicated logging server. Essentially, as long as log entries are being received, indexed, and queried on the Smart One appliance, Log Exporter can do the rest. True story, when I was in an operations role on the customer side some years ago, I used it to send filtered logs to a third-party SIM platform for event correlation. And this was an environment that handled about 10 gigabytes of logs per day minimum, and it performed surprisingly well. One aspect, however, and this is the subject of our time together today, is that logs in transit are unencrypted by default. So let's take a closer look at that. In today's world, any remote network destination is most likely more than a few hops away. And by hops, I mean passing through some intermediate device like a layer 3 interface, a physical router, or a firewall. And this is especially true for data traversing the internet. On the diagram on the right, you can see there are 7 hops listed there, and that's from a tier 1 internet carrier reaching an S3 bucket in AWS. So if a tier 1 carrier has 7 hops, you can guess how many maybe someone else has. So for me at my house here in southeastern Pennsylvania, it takes me 23 hops to reach the same destination. And the risks are real. Think of the things we see on the news: man-in-the-middle attacks, data monitoring, tampering. Any sort of assurance that your data is protected and secure as it traverses the internet is something that all of us, I'm sure, are thinking about. Think of it like this. If given the option to use Telnet or SSH, which would you choose? I think all of us would choose the inherently secure protocol, SSH. So how do we ensure data integrity and mitigate that risk of tampering? By using encryption, which is driven in this talk today by using identity-based authentication. So let's look at that a little closer. One of the ways we authenticate communication every day, in fact, whenever we visit an HTTPS website, is by validating the server's identity. And we do this using certificates. We, the client, verify the server's identity by validating the certificate that the server holds before we transmit any data. Mutual authentication does the same thing, but adds the reverse direction. The server validates the client's identity before permitting any communication. And this is especially common for applications like IoT communication, where you'd want to validate the client before permitting access to send data or retrieve information from a server. The same is true for API calls. You only want to make sure that authorized clients are permitted to make those calls to your web endpoint server. And as you might have guessed, we're talking about certificates because that's the type of authentication Log Exporter utilizes for mutual authentication. Both the sender which is the management server or the log server in this case, and the receiver, again, that external log server, trust each other's identity by first trusting the certificate authority who generated the certificates to begin with. Because that CA is trusted, certificates issued by the CA will therefore be trusted by association. I want to show this diagram briefly of what happens from a high level when a client and server use mutual authentication. Steps 1 through 3 are those we use every day when browsing the web. Client connects to server, verifies server, and moves on. Steps 4 through 7 are effectively added by using mutual authentication. If you were to step through a packet capture, in fact, you would see all of these steps laid out towards the beginning of the capture. All right, so what do we actually need to utilize this in our environment with Log Exporter? Well, the 3 components we need for securing logs in transit are first, a trusted certificate authority. This can be an internal Linux or Windows CA you use in your organization, or it can be a well-known trusted CA like DigiCert, Sec2Go, or Let's Encrypt. Next, we need a certificate generated by the CA for the management server to use as its identity certificate. We would do this by first generating a private key that corresponds to the management server, then a certificate signing request, or a CSR. This would be signed with that private key and then given to a certificate authority. Using that CSR, they then generate the final identity cert. Finally, we need a second identity cert generated for the external log server. We would use the same request method and process with the CSR sent to the CA as we would for the smart log or smart management server rather. All right, so that's enough slides. Let's jump over to the actual environment that I'd like to show you here today. All right, I think everyone can see that, so let's dive right in. This is a management server that I use here at home, actually, and I have a couple of items on here I'd like to show you. If you've never seen the syntax before, cp_log_export is the base command that you can run. Obviously, you can type help to get information about different sorts of config commands that you can run. The one that I'm going to actually take a look at here is status. This is a very brief output that shows us currently configured logging export destinations on my management server. You can see, however, that Splunk and syslog ng plaintext are not running. However, this one, LAAS, or logging as a service, is running. Fun fact, that's actually a component of R8120 that integrates directly with our IoT platform in the Infinity dashboard. It's a different discussion, but kind of cool to see it here. I actually didn't realize that showed up there until recently. But taking a closer look at these, the one I would like to show you first is the syslog ng plaintext. The target server IP address is this guy here. I'm using standard port of 514 over UDP for syslog. And what I'm going to do here is, because this is not currently running, I'm going to start this up with a handy pre-formatted command. And as I do that, I can see the process changes to started successfully. And if I jump over to that syslog server, what I would expect to see here is a specific log file being generated inside my directory. And sure enough, there it is. These can get pretty large pretty quickly, so I'm not going to run this for too long. But what I would like to do is do a capture on this. Again, formatted here, so you don't have to watch me type it out. I'm going to let that run for just a few seconds, and that's probably good. Yep, 52,000 packets is probably sufficient, and a whopping 120 megabytes in size. So, okay, great. And how does that really help us? Well, if I tail the last 10 lines of that file, what is it that I would expect to see? Well, hopefully we see logging information. And sure enough, we do. If I pick one of these, I can see the timestamp, I see the source IP address, and I can see everything else in there. Details about the action, what rule is it hitting, what NAT rule am I hitting as well, and simply what is the translated source that I'm using to reach this destination on the internet. So that's fine on the system itself, but what we're really talking about here is whether or not this is going to be encrypted. And as we would expect to see, the answer is no. So let me pull this up and open this in Wireshark, and we're going to confirm that this plain text log is essentially going to show us the same information in Wireshark that we see right here in our logging output. And so here's Wireshark, and here you can see our source address, of course, is the SMS. This is our destination server, and right away you can see within the payload details. I mean, that's as plain as can be in terms of traffic. So if I were an attacker or a malicious party or somebody sitting in between these two IP addresses, I would pretty quickly be able to pick out quite a bit of information about the traffic I'm sending, and indeed about the environment that I have running here. So I can see all sorts of host names. I can see information about addressing. That pretty much well corresponds to exactly what we don't really want here. So we're going to minimize this. I'm going to go back to our instance, and I'm going to stop this for a moment. And what I'd like to now show you is what the process looks like to build an encrypted method for sending those same logs to my syslog server, this time using TLS. So the first thing that I'm going to do on the SMS itself is I'm going to configure a new destination. Now, you might say, well, hold on a minute. You already have that IP address in here. Can you reuse that? And the answer is yes. I'm using a different target port, and I'm using TCP as my protocol. So I can define this again as the same destination, but this time I'm going to be using a different mechanism, of course, to send those logs to it. All right, so I'm going to execute that command. That completes. Now, notice something here. It says to apply the changes, run this guy in particular. All right, I have to start the service because it's not currently running. If I take a look at my configuration, you'll see that it's there. All the settings that I just put in are here. However, if I take a look at it this way, you can see that that is not running. All right, so the first thing we're going to do before we get that configured and rolling here, we're going to jump over to the directory where this configuration resides. And there's a shortcut or a link, if you will, called exporter dir that I can put in here. Targets syslog ng is going to take me to that directory. If I take a look at the contents, I have a couple of things here. The one that we're going to look at in a moment is this XML file. But before I do that, I'm going to create another new directory inside this called TLS. And the reason I do that is because I need to store certificates in this directory that my XML config is going to refer to. Now, I already have certificates here in my home directory. I have my CA certificate, PEM format, and I also have my client identity certificate in PKCS12 format. I'm going to copy both of these guys into my TLS directory so that I can then refer to them in my XML config. So let me do that now. Make sure that looks good. It does. So I am going to open up that XML file, and we're going to take a closer look at some of the changes we need to make next. All right, this looks a little busy because I don't really have a lot of good color coding inside my terminal prompt. But the section I want to point out to you here is right here where it says transport. This is where we configure all of our TLS configuration. And the way we start that is by going up here to the security tags that are open and closed. And there's two choices that we have here that Checkpoint gives us: clear, meaning nothing, or TLS. So I'm going to insert TLS there. 2 lines down is my PEM CA file, which I referred to earlier. I'm going to grab the full path. You can also use the shortcut path, that's fine. But I'm going to use the full one just to be absolutely sure this is the right area. And I'm going to move down to the next line and repeat the same process with my client cert. Again, this is my PKCS12 file that I have already pre-built. Now, finally, there's a certificate challenge phrase that I need to put in here. And this was originally generated when I create my identity certificate that I use to sign my CSR request and then send that to the CA. So I'm going to put in a passphrase here that is super secure. The good news is this is obfuscated and masked whenever I restart the service. So this will not show up like this for anybody looking at it later on. With those changes in place, I am going to exit out, save my changes, and I'm back to where I was in the original directory. So here we are. All right, that's great. I have all my configuration in place. All I need to do is start my service. But before I do that, I'm going to jump over to my syslog server once again. And I am actually going to use this tab that I have open. And I'm going to start another packet capture. And the reason is I want to be able to see what these packets look like in flight, specifically as they're reaching the interface of my syslog server. If this is working as I hope it will, these should be encrypted and completely unreadable. So let's start this. Shouldn't be a whole lot there yet. I'm going to go back to my logging directory and just take another look at what I have. And there we are. We still have just that first log file. Back here on my log exporter server, I'm going to issue this command to start it. And there it is. It's started. If I refresh and I look at that directory again, sure enough, there's a new log file, demo TLS, and that is growing really fast. So I'm going to cancel this packet capture. I definitely don't want that to be too big. And I'm going to pull that down. While that is copying, and we'll open that in a moment, what I'd like to show you momentarily here is a really useful way to check whether or not TLS is being utilized. Notice we have this debug file listed here. I can copy that and I can look at the contents. And further, I can grep for the word certificate. Now, if you looked at this line by line, you would see a lot more detail. But what this is telling me is the SMS service that's starting this log exporter instance is referring to the client cert and the CA file that I previously configured in an XML config file. So this is really good news. This shows me that that CA cert and PEM cert and the P12 as well are all being utilized within that instance starting. So that's great. Let's do one more thing here. If I pull up Wireshark, I'm going to open that file and we will have a look. All right. So at the very top, being that this is TCP, right away, I see what I would expect to see, which is my three-way handshake, SYN, SYNAC, and ACK. So client, server, client, that looks good. Further down, this is looking good too. Client hello comes in from the SMS to the syslog server using TLS 1.3. The server hello continues sharing its encryption capabilities. If I open these up, I can see all sorts of detail around what's being offered. But what I'm really curious about is where I see application data. If I cruise down a little bit, what I should see here is a payload that is completely garbled. And sure enough, I do. This is not discernible as anything really. And if I were to open this up and follow the TCP stream, I would see a very similar output with completely unusable information, which is exactly what I want. So that looks great on the packet capture side, but what about the actual log server? Encryption does me no good if I can't decrypt it once it's reached the destination. So let's take a look at that. I'm going to do tail and 10 again. Yeah, let me grab this directory. And hey, there we are. Sure enough, there's our timestamp 11/20/59. That is still running actually. So if I refresh this, you're going to see that timestamp update. Should probably really stop that, but that's okay. So this is, again, TLS delivered logs on my log server, decrypted, ready for me to search, ready for me to massage and utilize in whatever way that I'd like. but the capture with all the in-transit packets in between is completely obscured by TLS, which is exactly what I want. So that is great. And what I'm going to do now is stop that so that I'm not continuing to fill up my disk. Pending time, I think we have a couple of more minutes here. What I'd love to show you next to wrap it up is how this works with yet one more logging server environment. And that is going to be Splunk, actually. I have a Splunk environment that I built specifically for this. Splunk is obviously a very popular logging destination for a lot of organizations. I've used it in the past. I'm sure many of you have at least heard of it. And what I'd like to show is that this does work with TLS. I'll be honest, it was not as straightforward as syslog, so I'm eager to show you that it works, and also, of course, give you some information around how you can get this to work with some steps. So again, if I take a look at my pending list, I have Splunk in here, but it's currently not running. So before we start that up, like before, I'm going to take a jump over to my Splunk server. I'm going to start a packet capture in the same way that I did previously. And over here on the SMS, I'm going to simply start that exporter instance by issuing this command. And there it is. It started. So let's jump over to Splunk. Again, I'm waiting a couple of seconds here for that capture to run. I'm going to cancel that. We already have quite a few packets. And while I am downloading that capture to take a look at in Wireshark, I'm also going to show you the web UI to see what this looks like in real time. All right, there's my index main, and wow, even in a couple of seconds, I am already up to almost 40,000 events. So I suppose I should maybe be a little bit less eager on my verbosity for these logs. But here you can see pretty quickly that any one of these entries shows quite a few fields that are searchable. I mean, I can add any one of these to my search parameters. I can add this or exclude it, of course. And I can even go in here and say, you know, I want to search based on these JSON formatted key value entries where I have an action reason that was, oh, it's an early drop. Okay, this isn't policy based. It's an optimized drop within my rule base. I have information on an SK that I can utilize, of course, to see more details on that. But this looks really good. And man, I'm almost a little bit embarrassed about how many events this is generating in just a couple of seconds. So you didn't see that, but there it is. So jumping back over here to Wireshark once again, I'm going to open up my capture from Splunk that I just took, and we are going to confirm that the packets in flight are sure enough encrypted with TLS. And sure enough, you can see that the TCP three-way handshake, of course, client hello with TLS, server hello, certificate, key exchange using TLS 1.2. And then as I go down, application data, once again, is secured with my TLS transport mechanism, which is awesome. That's exactly what I want. So that is all that I had here in the demo. I am just going to jump over here real quick and stop these so I don't blow up my hypervisor with disk alert issues. I think we're good actually with just that. All right, great. So that's the demo. Let's jump back over to our slide for just another moment. I have just a couple of more things that I wanted to run over with you. All right. So to wrap up, I wanted to share a few resources that I really found helpful. The first is Checkpoint's official secure knowledge base article 122.323, which is where you'll find lots of information related to Log Exporter. Second is a command reference for OpenSSL. You might ask, well, why are we talking about OpenSSL when this is a Checkpoint presentation? Checkpoint actually uses a custom built from source version of OpenSSL, and many of those commands are almost exactly the same in many cases. There are a lot of really great troubleshooting commands here that I think you'll find really useful. And finally, the full document with all the details that I've gone through here today, and a lot that I haven't as well, is something we're working on posting alongside the recording. This will include specific steps for how to set this up in your environment, including how to generate a private key, a CSR, installing certificates, managing an internal CA. All of that stuff should be coming soon. So please look for those updates as well. All right. And that's a wrap, almost. To recap, we looked at what Log Exporter does and why mutual TLS authentication is important. We looked at the different components needed and the configuration for different scenarios. And we looked at successful log delivery to both syslog NG and Splunk, utilizing encrypted data in transit. Thank you very much for your time, of course, and attention. Once again, Rob, I will hand things back to you.
Yep, we got a couple of questions. I think you answered most of them, but we'll revisit. And one, of course, was, is this documented? And as you said, it's coming soon, right?
Yes, yes.
Hopefully this will be a full-blown SK article at some point.
Yep.
But if anybody, wants to get their hands on that now, reach out to me or Michael or your SE, and we can get it into your hands. But there'll be official documentation coming.
And a quick note on top of that, the SK does have some information about TLS authentication. It's a great starting point. What I've tried to do with our documentation is add to that and really give you additional help, because I definitely needed it. I mean, going through this, I wasn't a pro by any means, but hopefully you'll have what you need as we get that out there.
Yeah. And let's see. Is there a list of logging destinations that it works with, or it's just open, right?
That's a great question. So it will work with pretty much anything that can accept a client server TCP based communication mechanism. One of the challenges with this is that even though, something like syslog NG might be well documented for using TLS for log delivery, Splunk has its own set of documentation. Our syslog has its own set of documentation. I mean, SolarWinds has a syslog implementation as well that is going to have its own documentation as well. So I have not come across any limitation in terms of destination, but I would say to check the documentation of how that vendor handles TLS authentication. And if it's supported, I would say go for it. Give it a shot.
Great. And how about any limitations on what Checkpoint products to do? How about SMB or cloud or open server? Anything in there?
Yeah, that's a great question. So SMB appliances will work, but not using the same exact process. SMB appliances have their own web-based utility that you can use to define a logging export destination. So you can do it, but it is going to be handled within there. I believe TLS is supported within that implementation. So it's simply a different way of approaching it. As far as open server goes, that's actually what I'm running on. Hardware, of course, as well, is fully supported. As long as you're running R80 dot something, I believe it's a very well documented and well supported solution. Smart One Cloud is also supported with TLS. I actually have a section of my documentation that points out some of the high level steps of how to do that. That has been tested with great results. So yeah, aside from SMB being a little bit different, I don't think there's anything that comes to mind that would be a limiting factor.
Oh, great. I think that covers it for questions. Thank you, Michael. Great information.
Yeah, thank you.
Yep, we will send a follow-up email with any reference content and the recording link of this session. Our next webinar will be in 2 weeks. The topic for that will be Maestro. Don't know the specific content yet, but it will be a Maestro focused session. So you'll see an invitation for that soon. With that, we'll let you go. Thank you for joining us. Michael, thanks again. Oh, wait, we got another question maybe. Oh, great stuff. Thank you, Andrew.
You are very welcome.
Not a question, a compliment. There you go. We'll leave with that. So no, thank you all for joining. And yeah, we'll see you here next time.
All right.
Enjoy
Thanks,
your day.
everyone.
Thank you. Bye.